Why probability? What is probability, and how is it different than a statistic? A probability is how likely a certain event will occur. We use this language all the time. For example, how likely is it to rain today? Will the Dodgers win? Or if I invest my money in a pencil factory, how likely is it that I will make a large profit? Answers to these questions are very often very likely or probably not. But these answers are very vague. We are not exactly sure how likely something will take place. We just sort of have a feeling of it. In contrast to this, saying there is a 70% chance of rain is much more informative than saying it is likely to rain today. A probability in math is more than just a bet or a hunch. It is a numerical expression of how likely something will happen. It could be a fraction, a percentage, or a decimal. A statistic, however, is a number that describes a data set. If we had a bunch of test scores, and the average of these test scores was 72 out of 100, that number would be a statistic, since it describes something about all the tests. If you came into a room before getting your test back and the teacher announced that the average score was a 30%, would you be excited to get your test score back? Despite not knowing your score, that statistic tells you something about the class in general. Someone, at the very least, did not do well. When we say we are studying statistics, we are saying that we are studying, collecting, summarizing, and organizing facts based on data and using them to come to conclusions. For example, Chad has to be at school by 8:30 to be on time. Chad, however, doesn't always wake up on time, so he doesn't always make it on time. How can we determine the probability that Chad will be on time on a particular day? Obviously, if Chad is nearly always on time, we expect him to usually be on time. And if he is usually late, then he will probably be late. But how likely is it that he will be on time? These answers are too vague. Can you come up with a way to describe this numerically, similar to the 70% chance of rain? Go ahead, pause the video, think about it for a split second. All right. So first, we're going to need to gather some data, meaning we're going to need some actual facts about how often Chad is on time or late. Using this data, we will be able to find a probability that Chad will be late. Say we watch Chad's attendance for 30 days. 24 days he was on time, and 6 days he was late. If we had a chart showing Chad's attendance, it could look like this. Here, we are looking at statistics. That 80% and 20% are numbers that describe our data, which are the number of days Chad was on time or late. Using this data, we can see that Chad is on time 80% of the time. If we picked a day from one of the 30 days, then there is an 80% chance he will be on time. You might wonder, what about the next day, the 31st day? For that, we would need information about the distribution, which is a topic we will get into in another video. That 80% is a probability. In this case, 80% is both a probability and a statistic. It says something about the data set as well as tells us the chance that something will occur on a particular day. This is also much better than just saying he is likely to be on time. We can now say there is an 80% chance that in one of these 30 days that he will be on time. Now we need to understand where that percentage came from. The idea of probability boils down to a pretty simple fact. Events happen or they don't. We want to see if Chad was on time. That was our event. We decided to determine the probability by comparing how much it happens versus how much it could have happened. What do I mean by that? Well, it's kind of like how we compare how full a glass of water is. Say we have a glass that is half full. We compare how much water is there to how full the cup could potentially be. And this gives us a good idea of how much water is there and how much is not. It doesn't matter if the cup is big or small. We know that a half full cup is half full. Ratios, and by extension fractions, have this ability to state how much water is present without ever actually saying how much water is really physically there. It all depends on the size of the cup. If there was a cup that was 3/4 full, we would know how much that is. And if it was 1/4, then we would know how much that is for any size cup. As soon as they tell us the size of the cup, we can tell you exactly how much water that actually is. A probability is like this. How much something happens is like the water filling the cup, and the probability is how full your cup is. Notice the cup can't ever be more than full, otherwise the water would spill out. Similarly, a probability can never happen more than it could have happened, because that would make no sense. In math, we have a tool for doing this. It's fractions. We said half earlier, right? That's just 1/2. If we were to say 50% of the time, that's the same thing. Now in probability, we could say it's kind of like our water example, how full the cup is divided by how full the cup could be, which is just a fraction. And this is the same thing as the event happens, because that's like the water in our cup, over the event happens plus the event doesn't happen. It's the part of the cup that has water plus the part of the cup that doesn't have water, the entire cup. This ratio will give us a number based on data that informs us of how likely an event will happen. In Chad's case, there were 30 times he could be on time or late. So the bottom number is 30 because those are all the days he had the chance to either be on time or to not be on time. However, our event is him being on time, which only happened 24 times. So that is the top number. So we get 24 over 30, and when we divide it, we get 0.8. 0.8 as a percentage is 80%. It's important to note that this fraction, this decimal, and this percentage are all expressing the same fact. It's the same probability. Notice that as soon as the number of days increases, say from 30 to 40 days, this ratio could change, and our newly updated probability could also change. A probability can be updated as we gain new information, an important insight that will be used later. We give the bottom number a special name. We call it the sample space. So we can say that the sample space is simply the addition of the event happening and not happening. We can also say then that the probability is equal to the event happening divided by the sample space. That is what a probability is. Notice that this ratio can never be greater than 1, because that would mean that the event happening happened more times than it actually could have, which wouldn't make any sense. So if you ever see a probability greater than 1, something somewhere is wrong. So to recap, a probability is how likely something will happen. It can be described by the event happening divided by the sample space. A statistic is a number that describes a data set. We saw the average as an example of such a number, and many more will be talked about. To finish this off, we also have a Check Your Understanding in the description below, which is just a series of pretty basic questions, just making sure you understood everything that's been said in this video. If you can't answer these confidently, then consider going back and studying on these topics and trying to identify what specifically you don't understand. Also, feel free to leave a comment and we'd be happy to help you out. There's also an answer key provided, and I would encourage you to only look at that after you've given the Check Your Understanding questions a really fair attempt. Thanks for watching, subscribe, and we'll see you in the next video.